Hello everyone, what is up and welcome back to the channel iRumors. Today we are going to be creating our very own external SSD. So I'm going to be showing all of you, I shouldn't say showing all of you. I would be doing together with all of you my very own SSD. Usually I'll be showing all of you how it's done after doing the same thing over myself. But today I'm going to be doing this together with all of you. So by creating my very own SSD, I do not mean that I'm going to be using my own NAND chips and doing the own micro soldering myself. That's not what we're going to be doing. There is some high level stuff that I'm not going to get in right now, maybe sometime in the future, but for now I'm going to be creating my own external SSD using the Lexa NM620 M.2 NVMe SSD and the Asus ROG Strix Arian NVMe SSD enclosure. So the question that many of you might be thinking is, why create my very own SSD? Why not just go out and buy the Samsung T7 or the Samsung T9 or the WD SSDs that are external, or some other brands, even the SanDisk, and just plug it into the computer and just make it work? I'll definitely be answering that question at the end of the video, so definitely stay tuned for that. But that is at the end of the video. But now let's get straight into assembling this SSD. We have our Lexa SSD, we've got our NVMe SSD enclosure. The first thing we got to do is to open up the enclosure. How is the enclosure? What is its technical specifications? I've already done a separate video for that, unboxing it and explaining how this whole SSD works. Same goes for the SSD enclosure. So you can take a look at that before coming back to the video. You can watch this fully and we'll go back to watching that video as well. The first thing that we're going to do is to open up this NVMe SSD enclosure. For that, we've got to take our SSD, take a SIM ejector tool. You can use this or use the one that's included in the box, and just press it through the small hole right beside the USB-C port. Just go in, press it through, and do not take it out. Sometimes the casing might just snap back into place. Push it in, hold it, and then you can just open the door. Once the latch has been opened, here you can see there's a small thermal pad here. But the good thing that I got about the Lexa SSD is it also has a thin layer of thermal pad on its own on top of here. So that's two thermal pads. So the first thing we're going to do is, you can see there's a small screw. We're going to be opening it. For me, I'm just going to be using the SIM ejector pin to open it up. Yeah, that works. You can definitely use a screwdriver to open it up. But for me, I think I'll just loosen it, and now I can just use my hands to fully loosen it. And there we go, the screw has been removed. Take the SSD, and here you can see there's a small cut here for the screw. We're just going to be placing this part in. And once that's placed in, is the NVMe SSD, and slot it in just like how we slot in RAMs. Just slot it into the hole, just go down, and just make sure it's aligned to the hole right here. Because if it's not aligned in, then that's going to be issues. And then just try to screw it back in place. This is not the most professional method that I'm doing, but I'm just going to be doing. If I want, I can definitely use a screwdriver and try to screw it in place, but I feel like this works as well. So I'm just going to be just screwing it back in place. And while you're screwing in, just make sure you hold the SSD as well on your hands, because sometimes it might just turn. But now, before we close the lid, like I always say in all our repairs, do not close the lid before the repair is done. So now I've already put it in. We're not going to close the lid yet, but we're going to be trying to boot it up. So what am I going to do? I'm going to take a USB-C cable, plug it in through here, and just put it aside for now. And once that's done, get my USB-C hub, plug it in, and there you go. The moment we plugged in, you've got all the RGB lights popping up. That's really cool. We've got it connected, and the moment it's connected, it's showing up on the Mac as allow accessory to connect. Now we're going to click allow this accessory to connect. That was not readable by this computer. That's nothing that's going to do. We're just going to click ignore for now. Once that's click ignore, we're going to go to disk utility. So let's click disk utility, and once that's done, you can see this is showing as RGSD SC1 and showing as media 1.02 terabyte. So what we're going to do is we're going to erase this disk, and when you click erase, let's just rename it to Lexa 1 terabyte. Okay, once I've named that, I'm going to format it to exFAT. So why exFAT? Because exFAT is the format that is both readable by macOS and Windows. I wanted this to work as a normal external SSD. So that is the reason why I've got to format it in exFAT. If format exFAT, it works with both Windows and macOS. This just depends mainly on your use case. But I recommend exFAT because just make it versatile with all the computers, so it's easy to read and write. This we can just leave it as it is, just to remove it. Once that's done, I'm going to create an erase. So it's going to erase and it's going to create a partition. So that's done. So once that's done, now the Lexa 1 terabyte is showing up on our computer. Now that we've got the Lexa 1 TB fully formatted and connected, open Blackmagic Disk Speed Test. Click on this, and we're going to click select target drive. That's done. We're going to click the Lexa and open. Now we're going to start our disk speed test. Let's start and run it. Those two results were definitely not expected. There's a read of 38.5 megabytes per second and a write of 227.6 megabytes per second. I don't really think that that is actually true for this drive. Maybe it's because I'm using my MacBook charger, I'm not sure, but let's try to test it out using an actual real world test. So here I've got the Lexa 1TB, and here as you can see here I've got an untitled folder 2, and here you can see that it's about 23.68, let's say 24 gigabyte folder. This is actually the raw footages for my videos, so I'm going to try to transfer it over to the Lexa 1TB, and let's see how long it takes. I thought that the MacBook timing was actually lying and it would take about 10 minutes, but I was totally wrong. This whole 23.68 gigabytes folder took, you can see, 12 minutes 17 seconds to transfer this whole entire file over. I feel like this speed might be able to change, and that I'll talk about in the review because I want to do more of testings before I come to any conclusion. But for now, this is the timing. Since I'm telling you how you can build SSD, the cost plays the most important part, and that's what I'm coming to next. The first thing that we need to talk about is the enclosure of the SSD, and that is $40. And as for the Lexa NVMe SSD, I paid $89 for it. So that brings it to a grand total of $129. So $129 for this 1TB Lexa SSD. But when you compare it to the Samsung T7 SSD, which is about $130, and thinking of getting the Samsung T9 SSD, that's about $160. But those are fixed and you can't upgrade them. But as for this internal SSD and this external enclosure, you can definitely swap them out. I buy this SSD today. Let's say after a while I just drop it somewhere and the enclosure or the PCB inside tends to have some faulty and it doesn't work. I can instantly just take out my SSD inside here and I can swap it out with a new enclosure for $40. I have this SSD and it fills up. I don't have to go around buying a new SSD. I can definitely go and swap out for another internal SSD, take it, put it back in, format it just like how I did in this video, and we are good to go. We can definitely keep upgrading it. You can definitely use just one enclosure for multiple SSDs. Of course, you don't have to take it out and keep swapping them, but hey, that's just something good to have. You can just take out this SSD, pop in back a new one, and that's definitely some of the benefits of doing your own NVMe SSD. And that is the steps on how you can build your own NVMe SSD. I wouldn't say you can just straight away take it and do it, but some of you might not be confident doing it. When it comes to doing your own NVMe SSD, the two things that we got to take a look at is which enclosure should you get and which SSD should you get. It's two different components, so I could have always gone the easy route and gotten the Lexa NVMe SSD enclosure and just gotten the Lexa SSD and just get it done with. But I actually like this just ROG SSD enclosure. For me, I'm someone who prioritizes capacity over performance. But despite whatever I say, money do plays a big part. I can't just go around and spend $200, $300 or even more than that to get a Samsung SSD with a heatsink and all of that. I wish I can do that, but that definitely would not be a good financial decision as well. So I decided that this would be a more budget, more affordable option. Discuss more about the SSD situation and a lot more in our review. Thank you so much for watching. That's how you build an SSD. If you like what you click the like button, get subscribed, turn on notification so you get notified whenever I post a video. Of course, your comments are really important to me. If you're going to be trying it, do leave me in the comments below. I would love to know it from you. Thank you so much for watching, and for all of you in the next one. Bye.